Good morning, dear students. How are you today? I hope you're fine. Today we are going to start a new book. It's called Pre-Algebra. Okay, so you have this book open. We are going to open the book. We have here Unit 1, Algebra and Integers. So we have Chapter 1, the tools of algebra, Chapter 2, integers, and Chapter 3, equations. Let's start. As you see here, Chapter 1, the tools of algebra, we are going to have Lesson 1, use the 4-step plan to solve problems. Lesson 2 and 3, translate verbal phrases into numerical expressions and evaluate expressions. Identify Lesson 4, and use properties of addition and multiplication. I'd like you to know what we are going to have. Lesson 5, write and solve simple equations, and then locate points and represent relations, construct and interpret scatter plots. Okay, so algebra is very important to learn. Why? Because it can be used to show relationships among variables and numbers. So you can use algebra to describe how fast something grows. Here, for example, here, the growth rate of bamboo can be described using variables. Okay, we will find the growth rate of bamboo in lesson 1-6. So let's go now. Okay, let's start here. Open your books, page 6, chapter 1. Okay, I have here what we are going to learn using a problem solving plan. What we'll learn, you will learn the 4-step plan to solve problems. We have taken before how to solve a problem. Choose an appropriate method of computation. Let's see. Okay, why is it helpful to use the problem solving plan to solve problems? Okay, the table here shows the first class mail rates in 2001. I have here the US mail. I have the first one. It costs $0.34, the second one $0.55, and so on. We have here, he asks me to find the pattern. Number A, letter A here, find the pattern in the costs. Okay, so then he asks me to find how can we determine the cost to mail a 6-ounce letter. Suppose you were asked to find the cost of mailing letter that weighs 8 ounces. What steps would you take to solve the problem? Okay, dear students, now I have here some steps in the problem solving. We have four main steps. So the 4 main steps for problem solving plan, it's often helpful to have an organized plan to solve math problems, and we can also follow these steps in any problem. So the following 4 steps can be used to solve math problem. Okay, and as you know, in the MAP test, it's word problems, and also in the SAT you have word problems, so you have to know how to solve the problems. Number 1, I have here to explore. Okay, I have here to explore. Explore here means what? Read the problem quickly to gain a general understanding of it. So I have to read the problem to know the information it gives me. The problem gives me some information, some data. Okay, ask yourself, what facts do I know? What facts do I know? And what do I need to find out? So I have two questions. They are very important. What facts do I know? What data do I have actually? And what do I need to find out? And the relationship between the two questions here. Okay, ask, is there enough information to solve the problem? Is there extra information? Okay, plan. Reread the problem to identify relevant facts. Determine how the facts relate to each other. Okay, make a plan to solve the problem. Estimate the answer. Number 3, solve. Use your plan that you have done. So use this plan to solve the problem. If your plan doesn't work, so revise it or make a new plan. Ask, what did I do wrong? Okay, correct your wrong or your mistakes. So then examine, after you have finished solving the problem, examine, check your answer. Reread the problem. Ask, is my answer reasonable and close to my estimate? Ask, Does my answer make sense? If not, solve the problem in another way. Okay, so here I have to know the first steps for, yes, for here problem solving. So here are some strategies you will use to solve problems in this book. Yeah, look at the pattern. Yes, look at the pattern. Solve a simpler problem, guess and check. Draw a diagram. We can draw a diagram here as a plan. Okay, make a table or chart. This is how can we make our plan in math problems. We can draw a diagram, make a table or chart, work backward, make a list. Okay, let's complete now. Okay, let's solve example 1 here. Use the 4-step problem solving plan. Postal service. Refer to page 6. How much would it cost to mail a 9-ounce letter first class? Okay, first of all, explore. First of all, we have here to explore. Okay, so okay, please give it to me. Okay, just okay, like this. Okay, you can see like this. So explore. The table shows the weight of a letter and the respective cost to mail it first class. We need to find how much it will cost to mail 9-ounce letters. So the first thing I have to know that I want to know what I want to know how it will cost to mail a 9-ounce letter. Plan. Make the plan. Do your own plan. Use the information in the table to solve the problem. Look for a pattern in the costs. Extend the pattern to find the costs for a 9-ounce letter. So solve first, find the pattern. Okay, first of all, my dear students, what I'm doing now, I'm finding the pattern. How can I find the pattern? We have taken this on grade 7, I know. To find the pattern between two here, I choose two here, two consecutive numbers. I have here from 0.34 to 0.55 and know the relationship between the two consecutive numbers. So the first step, what to do? Steps, Jannat, how are you? So the first step, I have to take the two consecutive numbers 0.35, 34 and 0. Yes, I can hear you, 55, and do what? Know the relationship between them. Okay, what do you think here? Yes, every time here I add positive 0.21. Every time I add positive 0.1. How did you do that? Again, okay, clear this to do it again. As you see here, I have 0.34. What happens to 0.34? To go to be 0.20, 0.55, I added 0.21. Okay, you know now the relationship between the relation between both consecutive numbers. Check your answer if your answer is right or wrong. Okay, I will go for 0.55 and 0.76 and do some subtraction here. 0.76 minus 0.55, so it will give me here 1 and here 2 and here 0. So my answer is right, 0.21. So the pattern here is to add 0.21, right? Okay, so okay, go. So each consecutive cost increased by $0.21. Next, extend the pattern. Okay, we have here 5, 6, 7, 8, 9. Okay, so every time here I add 0.21, it's easy now. So it would cost for $2.02 to mail a 9-ounce letter. So here again we want to mark this. It will cost what? $2.02. Okay, for what? For 9-ounce letter. Okay, dear students. Okay, examine. After you finish, don't forget to examine your answer, okay, to check your answer if you're right or wrong. So it costs $0.34 for the first ounce and $0.21 for each additional ounce, and this is the pattern, I know. So to mail a 9-ounce letter, it would cost $0.34 for the first ounce and 8 times $0.21. Okay, and so on. So my answer is correct. So I have here something new. I have here a conjecture is an educated guess. Okay, it's an educated guess. Okay, when you make a conjecture based on a pattern of examples or past events. So focus here. What's this conjecture? What's conjecture? Okay, a conjecture here is an educated guess. It's not just a guess, no, educated one based on something true, based on past events, or here pattern. Okay, pattern of examples. You are using inductive reasoning. In mathematics, you will use inductive reasoning to solve problems. Okay, so here use inductive reasoning. Find the next term in 1, 3, 9, 27, 81. So every time here I do what? Okay, it's based here on pattern of examples. So here every time I multiply by 3. So assuming the pattern continues, the next term is 81 times 3, so it will give me 243. Okay. B, draw the next figure in the pattern here. In the pattern, the shaded square moves counterwise. Remember counterwise? Do you remember? We have taken this last year together. So I have here, as you see, okay, come here. I have here, as you see, it comes here counterwise. Okay, so the shaded square moves counterwise. The shaded square will be positioned at here the bottom, the bottom left of the figure, as you see, from this side to this side, and then 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 down. Okay, as you see here. So what type of reasoning is used when you make a conclusion based on a pattern? What do you think? Excellent, I can hear you. I have here inductive reasoning. Excellent. Okay, so choose the method of computation. Choosing the method of computation is also an important step in solving problems. Use the diagram below to help you decide which method is most appropriate. Do you need an exact answer? If yes, do you see a pattern or a number fact? If yes, use mental math. Okay? Do you need an exact answer? No. So you're gonna, okay, want to mark this. So you're gonna estimate, right? Do you see a pattern or a fact? If the answer here is no, so are there simple calculations to do? If yes, use paper and a pencil, of course. If no, use a calculator. Okay, so as you see here, this is the computation. Okay. So example 3, choosing the method of computation. Travel. The graph here shows the seating capacity of certain baseball stadiums in the United States. About how many more seats does Comerica Park have than Fenway Park? Okay. Do you know here, this is what, by looking here, it's what? Here I'm going to make subtraction to know how many more. And we know how many more here, it means subtraction. How many more I have than you. Okay, easy, inshallah. So, Fenway has baseball's fewest seats. Boston's Fenway Park, opened in 1912, is Major League Baseball's oldest and smallest stadium, with a capacity of 33,871. So baseball's smallest stadium in terms of capacity, as you see here, I have here Fenway Park, Boston, okay, and I have Wrigley Field, Chicago, and Detroit, and Kansas, and San Francisco. Okay, and the numbers here beside them. Okay, so explore. How can I here know how to solve the answer, the question? So I have to, the first step, Jannat, remember, explore. Yeah, you know the seating capacities of Comerica Park and Fenway Park. You need to find how many more seats Comerica Park has than Fenway Park. I know now, I explore, I get the information from the question. So here I'm getting the information, and it means the data from the question, right? Okay, plan. Plan means what the questions uses the word about. So an exact answer is not needed. We can solve the problem using what? Okay, using here, I want to write here, using estimation. Estimate the amount of seats for each park and then subtract. Okay, we're going to subtract. This is my plan. The plan is what? Again, the plan is to do what? The plan is to I'm going to do some estimation, and then I'm going to subtract. So estimate, then subtract. So solve. When now this is the step for solving. Comerica Park, 40,000. Okay, estimation here means what? To round. So I'm going to round the Comerica Park. It's 40,000 Comerica Park indeed, here I have Comerica Park. I don't know, it's Comerica or Commercia. It's okay, it's a name. So Comerica Park, here 40,000. So okay. So Marwan, what do you think? Comerica or what? So here I have 40,000. It's already here rounded to the nearest, yes, to the nearest thousands. So no need to round this. And I have here Fenway Park. Fenway Park, it's what? 33,871. When you want to round it to the nearest thousands, what do you want to do? When I say focus, open your eyes now. I want to do what I want to